Okay, so we have just learned how to use an equation and how to find slope visually, both visually and using an equation. Now, there are some things to note where sometimes your slope is a perfectly vertical line, so vertical means up and down, or a perfectly horizontal line. The word horizontal means left or right. Okay, so this is a horizontal line here, it's only left and right. This is a perfectly vertical line here, straight up and down. Okay, so we need to know what happens when something's straight up and down or perfectly side to side. What are the slopes of these things? So it can often be useful for ourselves to think of slope as slope is the steepness of a line. Okay, so remember how steep something is. If you guys say something is super steep, that means it's going on a very vertical angle. If something's not very steep, well, that's a perfectly straight line. So let's understand vertical and horizontal slopes. So I'm going to zoom in here and we're going to focus on vertical lines first. So vertical lines are always represented as x equaling some number. Okay, so if we go down here, this line here can be simply represented as x equals -2. Because anytime you have a y value, if you said on this line, what is the x value and y is 2? Well, it's -2. What's the x value when y is 1? It's -2. Everything's -2. So you simply just say this line is x equals -2. This one would be x equals +1. And hopefully you can see the pattern here. This is simply x equals 3. So anytime you have a vertical line, it's simply just x equals some number. Now, how do we define the slope of this thing? So imagine standing on the edge of a sheer cliff and your friend asks you to describe the slope of the cliff. So if you and your buddy are standing on this cliff and it just drops straight down and he said, what's the steepness? Well, in mathematical terms, you really wouldn't be able to describe the steepness. You'd probably want to say some massive number. So when you're looking down, at the moment, the way we would describe it is we would describe it as undefined. There's no way to define the steepness because it's way, way too straight down or straight up. So I would say the cliff face is so steep, its slope is undefined. And that's how you describe slope of vertically straight lines. We call it undefined, or in mathematical terms, we also say, we usually just say undefined. Okay, so understanding why it's undefined. So the slope of a vertical line is undefined because your x coordinates never change. So let's think about the rise over run equation. So since the x coordinates never change, this means that your run, which is your change in x, is 0. Okay. Now, meaning when you go to use the slope equation, your denominator is 0, right? So here, let's talk about finding the slope of the blue line. You choose 2 lines here. We'll recognize our run equals 0. You never go left or right, you just stay. And then here we go up 2 units. So our slope equation for this would be m equals rise, which is 2, over run, which is 0. What's the problem there? You cannot divide by 0. So when this happens, you say undefined. That's how we describe something when we just divide by 0. What your calculator will do is it'll say it's an error. Okay, so 2 dividing 0, we can see here calc error. Your calculator might give just a different 0, but it just says, hey, you're trying to divide by 0, which is not possible. So that's how we describe it. We say that a vertically straight line is undefined. Okay. Now let's go over to a perfectly horizontal line. So a perfectly horizontal line So this is when y equals some number. So if we look here, in these cases, like this red line, we could describe this line as simply y equals 3. Because anytime you have any x value, y always equals negative 3. This one would be y equals 1. And then this one, since it's at negative 2, this would be y equals negative 2. Now, let's change our idea up a little bit. Imagine standing on a perfectly flat road and your friend asks you to describe the slope of the road. If you can only explain the slope using numbers, what would you say? So here, we changed up our idea a little bit. Imagine our friends are just on a perfectly straight line. Okay, how the heck do you define a perfectly straight road? Well, you would say the steepness or the slope probably is 0. If someone was like, yo, dude, how much slope is there on that road? You'd say, well, there's like 0 slope. And that's exactly how you describe it. You'd say this road is so flat, its slope is 0. Okay, so the slope of a horizontal line is 0 because your y coordinates never change. So if we use the same idea, so let's find the slope of this graph here, the purple graph. Remember, m equals rise over run. So notice we don't have to go up or down in order to get from this point to this point. So my rise is going to be 0, whereas my run will be, it looks like 2. To get from negative 2 to 0, we're going to go over 2 units. So this would be 2. And you are allowed to divide by 0. That's not a problem, okay? So if you go to your calculator and you do 0 dividing 2, well, you simply just get 0. So that's your slope. Slope simply equals 0 here. So that's what we kind of mentioned down here. When you plug this into your formula, the change in y is 0 divided by some number that you choose. That number might just change depending on what points you decide to try. And remember that 0 divided by any number is simply 0. So the slope of a vertical line is simply 0. And hopefully this page really sums up that idea for you. Remember, you can think about it in terms of like being on the steepness of a cliff, okay, that's straight up and down, that's pretty much impossible to define how steep this thing is. Whereas your road, if it's perfectly flat, you would say that there's probably 0 slope or 0 steepness. Let's see some slope dude review. So this little image can be nice to kind of just gather up what we've talked about. So remember, slope can be positive. We can define it as negative. And now we can either define it as 0 or undefined. And slope dude here, we can see as he's going up, as this goes up, this is a positive slope. And we can see him saying positive slope, puff, puff. As we go down, well, this slope is going in the negative direction. So we define this as a negative slope. So negative slope, no problem, because he just doesn't really have to work to go down. This is a perfectly straight line, so this is 0 slope. So we can see here, 0 slope, this is boring, okay? Nothing's happening, nothing is 0. And then you can see straight up and down, well, that's an undefined. There is no slope going on there, so slope not defined, uh-oh, and he starts falling down, okay? So what we're gonna do is in the next video, we will review all of this fun stuff, okay? Well, actually, this all has to do with positive, negative. So let's actually just do this example 5 here, okay? So for example 5, it says, determine whether the slope is positive, negative, undefined, or 0 using the given information. If possible, determine the magnitude of the slope. So here we have the slope of y equals negative 2. Now, lots of people mistakenly sometimes give the slope of this incorrectly because they see a y value. So it's always important, draw a really rough sketch if you can. So let's draw a rough graph of what this looks like. So here we have our points, and then we have, this is our y and this is our x, and at y negative 2 you have a line. So our line is found, and I'll move that up. There we go. So there's our line. That's y equals negative 2. Now what do we notice about negative 2? This is a horizontal line. And when you have a horizontal line, what do you say? Well, we say that this slope equals m. Well, we would define this as having 0 slope. So equals 0. Because remember, the change in y over change in x, well, your y is never changing. So it's 0 divided by some number, which is simply 0. So that's what we just learned above. So there's our solution for A. Okay, let's maybe move on to B here. So the line y equals negative 2x. So this one, you might think immediately that, hey, this does have a slope of 0 as well. But recognize you have an x coordinate. So now we need to use our other information, and we should graph this thing. So x and y. So let's find 2 points that lie on this graph, and then we can create a visual. So here, y equals negative 2x. Well, simply, we're going to plug in, let's maybe plug in 0 here, okay? So I'm going to figure out what y is when x is 0. So I'm going to plug in 0 for x. So that will be y equals negative 2 times 0. So I'm replacing 0 in for x, and that will be 0. So this is a coordinate point, 0 and 0. What happens when x is 1? Okay, well, when x is 1, this will be y times negative 2, and then I'm replacing that x with positive 1, so times 1, so negative 2 times 1 is negative 2. So there's a point when x is 1, y is negative 2. So this will be negative 2. Let's maybe plug in 2, and then we'll stop at that point. So y equals negative 2 times 2. Remember, I'm replacing that x value with 2. Negative 2 times 2 is negative 4. So when x is 2, y is negative 4. So let's plot these points. Remember, this represents the point 0, 0. This represents the point 1 and negative 2. And then this represents the point 2 and negative 4. Remember, we always list our x and then our y coordinate. So let's go 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, negative 1, negative 2, negative 3. Okay, so let's plot this point first. Well, that's just the origin point. So when x is 0, y is 0. So we are going to have a point right here. When x is 1, y is negative 2. So when x is 1, y is negative 2. So there's our point right here. And then when x is 2, y is negative 4. So when x is 2, y is negative 4. So that'll be down here. And we can see we can connect these points. And remember, we only need a few points to plot this graph properly. So there we go. It's a perfectly straight line. And now, visually, we can just easily tell that we're going down. So trending down as you go right. So this means that we have a negative slope. And you could easily find the slope here, right? let's just choose 2 points. I'm going to do this visually. So m equals rise over run. Now what's my, let's talk about our run to get from this point to this point. So my run to get from here to here, well, I have to go over 1 unit right, so positive 1 unit right. And then how do I get from here down to this point? Well, I go 1, 2 down. So this will be negative 2 units down. And this is my rise. This is my run. So I'm going to plug that in. What's my rise? Well, it's negative 2. What's my run? Well, it's positive 1. And that will give me a slope of negative 2. And you can see that we have a negative number and this is a negative slope. So it all works out. Okay, let's try this question out. Well, here, what would be the equation of this line? Well, this is simply x at 4. So this graph is x equals 4. Now remember, this is a perfectly straight line. And what do we talk about perfectly straight lines? That we cannot define the slope. So slope is undefined. Again, if you wanted to, you could choose 2 points. So maybe this point and this point, and find it. Recognize your run never changes. Run is 0 because you're not going left or right to get to the other point. Here, we're going 1 unit down, so negative 1 unit down. So that would be our rise, which is negative 1. M equals rise over run. My rise is negative 1, my run is 0, and you cannot divide by 0, so this would be undefined. Okay, let's do one last example here, and then you guys can go practice a few problems on your own. Just gonna section this part off here so we don't get overly confused. There we go. So a line that goes through points negative 2, 3, negative 5, 2. Well, here, I'm going to use my equation, slope equals change in y over change in x, and I'm just going to see if my slope ends up being a positive or a negative number. So this is y2 minus y1 over x2 minus x1. Remember, name each thing. So I'm just going to simply make this my x1 and my y1, and this will be my x2 and my y2. And then from there, we're plugging in these values. So wherever I see x1 and y1, I'm going to plug in negative 2 and 3 respectively. So where is x1? That's right here, so that'll be negative 2. So this is negative 2, subtract. What's x2? x2 was negative 5. And recognize I have kept the sign of my negative 2 here. Okay, what's my y2? Well, I've put 2 as y2. Subtract. And now what's y1? y1 is 3. And then from there, I'm going to plug this into my calculator. So here I'll go 2 minus 3. Which gives me negative 1, so this will be negative 1 dividing, and then I'll also do negative 5 minus negative 2. So negative 5 minus negative 2, and I'll put brackets in there. Okay, so recognize I have put a negative where I see them. That will give me negative 3. Now don't jump the gun, you want to simplify. Okay, so here, let's simplify this to the point where both our negatives cancel out. So this will be positive 1 over 3. So we have a positive slope. And if you wanted to draw a really quick graph, you could. Let's maybe do it and see what this actually looks like. So here, let's plot this first point, -2 and 3. So -2 and +3 would be right here. And we're just doing a really quick rough sketch. Okay. And then this point here would be -5 and 2. So -5 would be way over here, and then 2 is right here. And if we connect those points, you can see that we do in fact get a positive slope. Because remember, for linear relations or for a linear line, you only need 2 points. Okay, so this in fact has a positive slope. And we were able to determine that slope. It's 1/3. So every 1 unit up, go 3 units right. And we can check that. Every 1 unit up, so we're at -2, go up 1. So this is up 1. And then go 3 units right. 3 units right. Well, to get from -5 to 2, we got to go 3 units right, because this would be -4, -3. So 1, 2, 3. So 3 units right. So it looks like it worked. Okay, so if you have any questions, please come in and ask. This is kind of vital to understand moving forward, especially for the remainder of the course. Okay. If you have any homework or practice problems that I've assigned or that you can try out, I would suggest doing so, or just simply open up your textbook and give a few a shot. Other than that, have a wonderful day.